So this lesson is going to be about reading velocity versus time graphs. The learning target is I can use a velocity versus time graph to calculate the acceleration of an object. So this is a picture of me. This is fall of 2019, the first time I had ever ridden a motorcycle before. I was at church, and a guy that was at church had been asking me over and over all summer about, are you going to come ride a motorcycle with me? Are you going to come ride a motorcycle with me? But I didn't want to tell him that I had never ridden a motorcycle before. Finally, I told him, and in the fall he said, this is your last chance. It's your last chance. I'll teach you how to ride a motorcycle. You come ride a motorcycle with me. Come over and I'll show you how to do it, and we'll get you going. And so I finally did. And I was so nervous when I was starting because I thought that I had seen, videos of people when they would take off on a motorcycle and it would start to get away from them. And this right here, they'd start to pull back a little bit more on the throttle. And then what would happen was they would take off even faster and the motorcycle would get more away from them. And then they'd move faster because then they'd pull harder on the throttle. And next thing you know, if I was going to draw a graph of their position versus time, like we always do in science, describing everything that we possibly can with the position versus time graph, they would look like this. And next thing you know, they're just taking off and they're moving so fast. Right? If I was going to take a look at what the velocity would look like, what my velocity on this motorcycle would look like, remember in a position versus time graph, the slope of the line equals the velocity. So as I take off on this motorcycle, I see that the slope when I first start is not very steep. Right? It's not too bad. But as I pull back on that throttle and as the motorcycle starts to get away from me, my velocity, the slope of this line, becomes steeper. And eventually, as it really gets away from me and it just takes off, the slope is almost straight up and down, meaning my velocity is really, really high. And so I'm moving very fast. If I was going to graph the velocity versus time of this, so how my velocity is changing, because I don't just have a constant velocity, my velocity would be increasing. Right? And so we're going to be looking at this velocity versus time graph, in this lesson, and figuring out how can we calculate the acceleration in order to better describe the movement of objects. So now we have a better look at our velocity versus time graph. We're going to compare what this is like to a position versus time graph. So remember, with position versus time graph, position versus time, the slope equals the velocity. Because in a position versus time graph, the slope is the distance on the y-axis and the time on the x-axis. And so that fits up perfectly with our velocity equation. And so it's going to be kind of similar with our velocity versus time graph. So when I have a velocity versus time graph like I have right here, our slope, now that we changed our y-axis here, is now our velocity, and our x-axis is our time still. You can remember that this is the change in the velocity and the change in the time. And that matches up perfectly with our acceleration equation. So the acceleration equals the change in velocity, over the change in the time. And so if we're taking our acceleration, change colors just to make it stand out a little bit better, we could take acceleration equals the velocity final minus the velocity initial, divided by the time final minus the time initial. We could think of this as 2 and 1 again, like we did with the position versus time graph. But basically, we're taking the change in velocity over the change in time. So if I was going to do, let's look at what the acceleration is for the first second. My change in the velocity goes from 0 to 4 as I go up, my rise. So I would go 4 minus 0 meters per second. And my time change would be from 0 seconds to 1 second. So my change would be 1 minus 0 seconds. And so my acceleration would be 4 meters per second, and that would be meters per second squared. So with velocity versus time graphs, it's a little bit different than a position versus time graph. It's the acceleration is the slope of the line. So we're going to use that to calculate how our objects are moving. And so give this one a shot. Take these 4 questions. Go ahead and stop the video, quiz yourself. What's the object speed at 7 seconds? You're going to be calculating some accelerations. and doing some descriptions of the object's motion throughout this. This is a velocity versus time graph. And so let's look at what the object's speed is at 7 seconds. Now, because this is a velocity versus time graph, and this is where we get tripped up a lot, is because we switch back and forth between position versus time graph. So on our y-axis, we have velocity, and we're looking for speed. Remember, the difference between velocity and speed is the direction. So this is a positive speed, making it a velocity. And our object speed at 7 seconds, we go straight up from here, and because it's a velocity versus time graph, the speed is 6 meters per second, positive 6 meters per second. So for the acceleration of the object from 1 to 5 seconds, we're going to go the slope, which is the acceleration of a velocity versus time graph, is v final minus v initial over time final minus time initial, or time 2, time 1, however you want to think about it. We have the velocity final, we're going from 1 to 5 seconds, so let's go off the top here. We're going up from 1 up to 5. So we go 5 minus 1 meters per second. And our time change is from 1 seconds to 5 seconds. So we have 5 seconds minus 1 seconds, which is going to give us 4 meters per second divided by 4 seconds, which equals 1 meters per second squared. And so we can describe the acceleration of this object as it's gaining 1 meter per second of speed every second. So it is speeding up because it has a positive slope on a velocity versus time graph. So if we were going to try to describe the object's motion from 7 seconds to 8 seconds, this right in here. So we look at this line here and we can see what the slope is. The slope is 0. The slope is not changing. And in a velocity versus time graph, that means that our speed is not changing. It still means that it is moving at 6 meters per second, so it's still moving forward, but that speed isn't changing at all. And so we couldn't say that this is accelerating. It is not accelerating. And it is moving at a constant speed of 6 meters per second. And remember, if we put positive 6 meters per second, now we're talking about velocity. Velocity has a direction with it. So that's how we could describe the object's motion from 7 to 8 seconds using this graph. And so our last one here is what is the object's acceleration from 8 to 10 seconds. And we're going to go with slope. Since it's a velocity versus time graph, we're going to go slope is our acceleration, velocity final minus velocity initial, and we have time final minus time initial. And so we have from 8 seconds to 10, I'm going to start with our velocity. I'm going down from 6 to 2. So I'm ending up at 2, that's my final velocity. 2 minus 6 meters per second. I'm dividing by my time, which goes from 8 to 10. My final time is 10 seconds. And if you wanted to just think of this as it took 2 seconds for this to happen, that'd be fine too, whatever you need. So this is going to end up being negative 4 meters per second divided by 2 seconds, which comes out to an acceleration of negative 2 meters per second squared. And so we can check this because it's a negative acceleration. We know that they are slowing down in here. If we were going to describe the motion, the slope is negative. And so hopefully by the end of this lesson, you should be able to use a velocity versus time graph to describe an object's motion. Remember that for position, v time, the slope, oops, tried to write my e down there instead of up by time, slope equals the velocity, and for velocity versus time, the slope equals the acceleration. And so that key difference will be really important. The first thing that you should do is see is it a velocity versus time graph or a position versus time graph, and then go from there with describing the object's motion.